Okay, ladies and gentlemen, this is the third and final video for the Chapter 3, Section 2 notes from your geometry book. We're still, again, working with the theorems and postulates associated with parallel lines and transversals. In the last video, we wrapped up by doing this example. Notice how many different options we had for stating why certain angles are related to each other. So these next type of problems here, we're going to have to be more specific. Okay, we're going to have to think things through. Sometimes our thinking will be a one-step process, and sometimes it will take more than one step to get there. Okay? So in the picture, they tell us that the measure of angle 4 is 2x minus 17, and they tell us that the measure of angle 1 is 85 degrees. So the first thing that we should do is we should ask ourselves, is there a relationship between angles 1 and 4? And our vocabulary does not provide a direct example of a relationship between angles 1 and 4. However, we should be able to very quickly in our heads go, oh, well, the vertical angle theorem says that angle 1 is congruent to angle 3, which means that the measure of angle 1 is equal to the measure of angle 3. So the measure of angle 3 is also 85 degrees. And then we should be able to recognize that angles 3 and 4 are consecutive interior angles, which means that according to the consecutive interior angle theorem, the measure of angle 3 plus the measure of angle 4 must be 180 degrees. And based on that, we can now write an equation to solve for x. Measure of angle 3, we've stated, is 85 degrees because it's vertical to angle 1. Measure of angle 4 is 2x minus 17 degrees, and that equals 180. Combine like terms, 85 minus 17 is 68 degrees. Subtract 68 from each side of that equation. 2x equals 112, and divide by 2, giving us x is 56. Now notice that I'm not giving 56 a degree because x is not an angle measure, it's a variable. So the value of the variable here is 56. If we went in and plugged 56 in, we should find out that that angle is equal to 95 degrees, so that 3 and 4 add up to 180. Okay, so let's do another one. They're not always that advanced. Sometimes they're much simpler. For instance, here in this example, we're told that angle 3 is 4y plus 30, and angle 7 is 7y plus 6. Those two angles, angles 3 and 7, are alternate interior angles. The alternate interior angle theorem says that since R and S are parallel lines, that angle 3 is congruent to angle 7, which means the measure of angle 3 is equal to the measure of angle 7. So in other words, what we're going to do here is we're going to plug in 4y plus 30 for the measure of angle 3, and we're going to plug in 7y plus 6 for the measure of angle 7, and when we solve that equation, we have the value of the variable. So we go in here and we say, all right, we need to move the y to one side, so we're going to subtract 4y from each side. While we're at it, we'll go ahead and move the 6 by subtracting 6 from each side. That gives us 24 equals 3y. Then divide by 3, and that gives us our y value as 8. Y is 8. Done. Let's do another one. Okay, in this one we've got angle 2 is 4x plus 7 degrees. By the way, if you think you know what you're doing, you should pause the video and try this on your own before I get too far into it. Angle 7 is 5x minus 13. Now 2 and 7 do not have any direct relationship with each other. However, the corresponding angle postulate says that since R is parallel to S, angle 1 is congruent to angle 7, which means angle 1 is also 5x minus 13 degrees. Then the supplement theorem would be our next step. It states that since angles 1 and 2 form a linear pair, the measure of angle 1 plus the measure of angle 2 must be 180. Now looking at what we have in our picture, we've already established that the measure of angle 1 is 5x minus 13, and the measure of angle 2 is 4x plus 7. So by adding those together, we can create ourselves an equation. 5x minus 13 plus 4x plus 7 equals 180. Combine like terms, we've got two sets. 5x plus 4x is 9x. Negative 13 plus 7 is negative 6, equals 180. Add 6 to each side of that equation, gives us 9x equals 186. And then divide by 9. But Mr. Wills, 186 is not divisible by 9. You're right. However, that fraction does reduce. Both the top and the bottom can be reduced by 3, giving us x equals, 62 thirds. Okay, x is 62 thirds. One more of these, I believe. Okay, again, pause the video, try it on your own before I get too far into it. All right, angle 5 is a 68 degree angle. Angle 2 is 3y minus 2. There is a direct relationship this time between angles 2 and 5. Angles 2 and 5 are consecutive exterior angles, so the consecutive exterior angle theorem, I should say, says that those two angles, angle 2 and angle 5, are supplementary. So the measure of angle 2 plus the measure of angle 5 equals 180. So that'd be 3y minus 2 plus 68 equals 180. Combine like terms, 3y plus 66 equals 180. Subtract 66 from each side. Gives us 3y equals what? 114? Divide by 3. And we get y is 38. Okay, so that's the idea. We identify what angle pair we're dealing with. If there isn't one, then we use a two-step process to come up with what relationship we have. Are they equal, or do they add to 180? It is always one or the other. They're always, the two angles they give you are always either equal or supplementary. So based on your vocabulary, based on what you know about transversals, you have got to figure out what that relationship is and set it up. Okay? All right, so that leaves one slide to do in this section, and that is one more theorem. This theorem is kind of a duh theorem, by which I mean it's a theorem, so in theory it should be getting proved. But to be honest, it's pretty straightforward if you understand the corresponding angle postulate. So it shouldn't take a whole lot here. In a plane, if a line is perpendicular to one of two parallel lines, then it must be perpendicular to the other. Okay? Now that's pretty straightforward. So let's look at the picture here. Don't write anything down, just watch. Okay? What we're saying here, A is parallel to B. We've already got those markings. A is parallel to B. Which means that all of those other rules, corresponding angle postulate, all of those rules apply. Okay? Now the other thing they tell us here is that line M is perpendicular to line A. We should remember that that means that this is a 90 degree or right angle. If M is perpendicular to A, that is boxy. That is a 90 degree angle. Well, the corresponding angle postulate says if A is parallel to B, and this is a 90 degree angle, then so is this angle. It has to be 90 degrees as well. So this theorem is basically taking that as a shortcut. It's saying that if that line M is perpendicular to A, and A is parallel to B, then M is also perpendicular to B. That does it for our Chapter 3, Section 2 notes. Thank you very much for your time and energy.